Okay, so I'm going to be teaching you guys about nuclear chemistry, and in order to understand that, we have to first go through some definitions. So, first, a radioisotope is an isotope that gives off nuclear radiation. And nuclear radiation is radiation given off by radioisotopes decaying. And the three types of nuclear radiation are alpha decay, beta decay, and gamma decay. So first we're going to talk about alpha decay, and it is when a large atom emits 2 protons and 2 neutrons. And so it's written as helium-4 2. And helium-4 2 is the alpha particle, and that's how it's written. So this is a diagram of what alpha decay looks like. So you have a radioactive isotope. It's uranium-238-92, and so it's going to decay it's going to split up into 2 parts, helium-4 2, because that's an alpha particle, and to balance it out, it's going to turn into thorium-234-90. So these 2 particles here and here add up to make this big one here. So if you add up 234 and 4, you'll get 238 from right there, and 90 and 2, and you'll get 92 there. And so it creates a radioactive isotope. So now we're going to try an example, and so we'll go through it together. So it gives us bismuth-210, and if you look on the periodic table, bismuth's atomic number is 83, so we know 83 goes on the bottom here. And since it's alpha decay, we know an alpha particle is helium-4 2. So we're going to write that here. So we have to balance this side out and this side out. So in order to do that, you can do 83 minus 2, which gives you 81, and 210 minus 4, which gives you 206. So now if you look at your periodic table, if you look where 81 is, it is thallium, and that is TL. And so that's how you solve this kind of decay. Now we're going to move on to beta minus decay. There's 2 types of beta radiation. There's beta minus decay and beta plus decay. So we're going to start with beta minus. And beta minus is when a neutron changes to a proton to form an electron. And a beta minus particle is written as E-10. So it's an electron. So here's a diagram that shows beta minus decay. And so you start with a radioactive carbon isotope right here. And it has, and it's carbon-614. And it goes through beta decay. So goes through, and so this electron here, added to this equals this. So when carbon-614 goes through beta decay, it forms nitrogen-714, and because if you subtract 14 minus 0 is 14, and then -1 and 7 is 6. So now we're going to do an example of beta decay. So beta minus decay, the beta particle we know is an electron, 0, -1. And so if we look at the periodic table, aluminum, its atomic number is 13. So we can write 13. So now we have to figure out what goes here. So let's think in our heads. What minus 1 equals 13? So 14, so that would be 14. And then 28 minus 0 is 28. So let's look at our periodic table, and the element with atomic number 14 is silicon, which is Si, and that is an example of beta minus decay. The next type of radiation is beta plus decay, and this doesn't come up a lot, so we're not going to focus a lot of time on it. So beta plus decay is when a proton changes from a neutron to form a positron, and a beta plus particle is written as an electron plus 1, 0, and that's basically it for beta plus decay. Next is gamma ray radiation, and we're also not really going to focus on this one, and it doesn't really come up that much, but they are high energy electromagnet radiation, and it's kind of it's like how X-rays work. So next we're going to learn about transmutations, and transmutation is the process of converting one element into another using bombardment. So we're going to look at two examples here, and this will make more sense. So example 1, nitrogen 14.7 plus helium 4.2 equals hydrogen 1.1 plus blank. So our goal is to make the two sides even. And so in order to make them even, we're going to have to add an element. We're going to have to add an element at the end. So in order to find this, let's do the bottom number first. So 7 plus 2 on this side is 9. So we know that this side has to equal 9 also. We have 1 already, so 9 minus 1 is 8. So we know the bottom number here is 8. On top here we have 14 and 4, which equals 18, and here we have 1, so we can do 18 minus 1 equals 17. So we know the number up top here is 17. So if we look at our periodic table, the element with atomic number 8 is oxygen, and so that's how you would do this transmutation. Okay, here is another example of transmutation reaction. So we have molybdenum 4298 plus 1 neutron, and it's going to it's going to change to with an electron and another element. So, just like we did before, we need to balance it out. So on the bottom here we have 42. So, and over here we have -1. So that means over here we need 43. And up top here we have 99 and 0 here. So 99 plus 0, 99. So if we look at our periodic table, the element with the atomic number 43 is technetium, which is Tc, and now you can check your work and balance it out. So 42, 42, and 99, 99. And so that is your transmutation reaction. Okay, so let's move on to fusion. And fusion is the combining of two nuclei to form one nucleus of a larger mass. So let's look at a diagram to explain this. So deuterium and tritium, these are two separate nuclei, and when they go together, they form one nucleus of a larger mass. And so you see you have two protons, 1, 2, 3 electrons, and then 3 electrons here. So it just creates one larger one, and that's fusion. Fission, on the other hand, is the splitting of a nucleus, and then it releases energy. So here's a diagram. So a neutron goes into a nucleus, and it goes in and hits that, and then it splits into 2. 1, 2, and then from there it splits into 2 again and again and again, and that keeps happening, and every time it splits, it releases energy from the nucleus. I hope this helped your understanding of nuclear chemistry, and good luck on the midterm.